Hello everyone, my name is Eleanor Burgess. Today I'm going to tell you about a project done by a power group of researchers, clinicians, and interaction designers at Currie Digital Platforms, a technology innovation group within Elevance Health. Elevance Health, is formerly known as Anthem, is one of the largest health insurance companies in the United States. Today I'm going to talk about our work in the area of AI and clinical decision support tools. Imagine you're a primary care provider. You have 15 minutes for the patient visit. In that time, you need to build rapport, find out if they've had their screenings, their flu shot, answer questions about a new rash that they've discovered on their hand. You're typing all of this into your electronic medical record, and in the last 5 minutes, you have a chance to ask about their type 2 diabetes management. You see from their labs that their A1C is still at 10. You'd like to see that move closer to 7. You've already prescribed the medication metformin, and so now you're considering what to prescribe next, perhaps a combination of medications. In all of this, you have a new AI model tool showing up in your electronic health record. In this talk today, I'll talk about the question of how do we design for this environment. In this work, we studied a prototype powered by a validated AI model, which presented type 2 diabetes medication insights, particularly around combinations of type 2 diabetes medications. Type 2 diabetes is a condition managed by 462 million people worldwide, and in the US alone, accounts for nearly a quarter of all our healthcare spending. So today I'm going to talk about how we started our project with a robust AI model, and then through interviews with clinicians, rapidly realized that the actual decisions that they were making were fundamentally more complex and had more variables than we had originally anticipated. And therefore, we join many other HCI studies in really noting this socio-technical gap between the design system and the messy realities of everyday life. I'll also talk about how we learned that AI tools are only aware of some part of the story and don't have the full view of information that a clinician might have with the patient in the room. And also that when they have the patient in the room, that's an incredibly time-constrained encounter, and they don't have time to sit down and really research and figure out the AI systems. And then also I'll talk about how these AI tools represent a new form of knowledge creation in healthcare. And so that has implications in how we're building trust and how we're helping clinicians make sense of that information. Our research goals were to deeply understand the workplace context and challenges of medication prescribing, and to use participant feedback to carry out rounds of design iteration on the AI-based prototype concept. So through interviews with 41 different clinicians from a variety of different roles, all of whom could prescribe type 2 diabetes medication, we constantly iterated through over 100 different visualizations to really refine and bring our prototype mock-up to really match the needs of clinical practice. So what did we learn? First, drawing on Kaye et al.'s concept of a design objective, we started with a single one, which was to reduce A1C level. However, what we learned is that there are many different considerations that clinicians go through around which particular medications and medication combinations they'll choose to prescribe. For instance, what a person does for their job is very important. For example, if a person is a gardener, they might not have access to a fridge to keep some medications cold that need to be refrigerated. Also, if somebody is a cardiothoracic surgeon, they're certainly not going to want a medication that's a diuretic, meaning that they might have to pee in the middle of long surgeries. We brought these learnings into the design of our interface, where first we enabled the clinicians to filter for these considerations that are very important that we had discovered and talked about earlier, and also we highlighted through callouts particular points of information that might be useful for clinicians as they're comparing and contrasting different medications. So things like whether a medication might have cardiovascular or renal benefits, or if it is an injectable, which is important if someone's afraid of needles, or if it might cause hypoglycemia risk. We also learned that it was important to front load our trust building for these new AI-informed tools. And there were many facets that clinicians wanted to know about. For instance, how is the insight calculated? Which organization developed the model? What are the data underlying the model? And making sure those are answered up front was very important, not only to build trust, but also to help the clinician figure out how to use the tool in their everyday practice. So what does this mean for the design of AI-supported clinical decision support tools? In our work, we see that there was a difference in the amount of information available to the clinician who was sitting there within the office with the patient and that which was available to the model. And therefore, we see the importance of considering the AI-supported system and the clinician working in collaboration. And in terms of operationalizing for our project, we gave the clinician agency and control over the model output through the use of filters. Our next main point is that AI and ML systems need to fit into an already constrained patient visit workflow. So what does that mean? Well, first, we'd recommend not introducing research tasks into the patient visit workflow. We actually spent a lot of time making different visualizations of A1C change over time with particular combinations of medications. However, clinicians don't have time to sit down and sift through that, and so it was considered not helpful. Secondly, we recommend pinpointing where complex decisions need to take place in a clinical workflow. So in our context, there's a lot of resources around first-line treatments for diabetes medication, but then when that first-line treatment doesn't work or doesn't work as well as expected, then that second-line and third-line treatment are really where these systems can be particularly valuable in suggesting certain medication insights. And then finally, because this workflow is so constrained, it's not a great place to build trust for the first time. So we recommend building trust early during onboarding and the first couple uses, and then maintaining it in the context of use within the patient visit workflow. And this is particularly important too for us to think about, right? Our own work and many papers in the related literature talk about the AI system being introduced to the clinical workflow. However, we see a future where more and more AI systems are introduced into the workflow, and clinicians need to be able to trust and work with all these different potential future tools. So it's important to think about that and make sure that all these systems can work seamlessly together with the clinician within these already constrained patient visits. Taking it up another level, we see that healthcare providers are reconciling AI as a new form of knowledge production, where previously the process started with clinical trials, which then moved to published papers, and then through several processes resulted in medical guidelines. And now we have a plethora of real-world evidence and data that's running through different AI and ML models, resulting in these AI-supported insights. And yet clinicians don't necessarily know how to make sense of these insights in relation to these prior and current medical guidelines. And so helping to support that process is something that's very important for all of us making these type of systems. So in conclusion, as we all know, tasks in healthcare are complex and multifaceted, and AI tools will likely never know the whole story that's available to the clinician sitting in the room with the patient. And so we advocate for putting the power and interaction ability in the hands of the clinician to do that important work of contextualization and personalization. We also see that there's an ongoing process of introducing AI into clinical knowledge generation and decision-making processes, and so paying special attention to our onboarding and to introducing AI knowledge generation learnings into medical school teaching and continuing medical education, we believe would be very important moving forward. Thank you.